Hi, everyone. We're going to start lesson 25 on interval estimates. We're going to call these confidence interval estimates of population parameters. So what if, instead of a single value, a point estimate, what if we're allowed a whole range of guesses, not just a single point estimate? First off, let's discuss the idea of sampling error. All right, so here's the idea. We have a population, maybe test scores in a big lecture class. And from this, we draw a sample. All right. Well, this sample, it could be 5 students, let's say, and their test scores. A sample often does not represent the population or probability perfectly, and this often leads to sampling error. So although we hope this random sample, who knows, it could be a systematic sample for that matter, who knows if this sample really is that representative of the overall population? We hope it'll be. We believe it should be, but it may not be representative of the overall population, and it probably is not perfectly representative of the overall population. What's going on with 5 students may not be exactly what's happening with 1,000 students. Now, a point estimate, typically a sample statistic, such as the sample mean, x bar, may or may not equal the true value of the population parameter that's trying to estimate. So for example, if we take a sample mean for the sample of 5 students, we hope that it'll be close to the population mean for all 1,000 students and their test scores, but the odds are it's probably not exactly on the mark. We hope it'll be close, but we do expect some sampling error. All right. So again, on sampling error, example 1, A, the population mean for a class exam could be 75 points. Okay, so it turns out that the mean for all the scores may end up being 75 points after all the tests are graded. But the sample mean, when only 5 tests were graded from a random sample, the 5 tests may have only had a sample mean of 74 points. But you see how this is quite possible, how overall the class mean may be 75 points, but the sample of 5 students happened to average 74 points. You can see how this is quite possible. So it's not surprising at all that maybe the population mean is 75 points, but the sample mean was only 74 points. That would not be so shocking. Later on, we'll see cases where it would be shocking. For example, if the sample mean were 20 points, then perhaps the discrepancy would be shocking. Then it's probably not just chalked up to sampling error. Part B, a fair coin may come up heads 51 times in 100 flips. So you can imagine this here as being, I guess, infinitely many possible alternate universes where we're flipping this coin. All right, well, if it's a fair coin, then P, the probability of heads, will be 0.5. Let's say we do have a perfectly fair coin. Not that one really exists, but let's assume that we have a perfectly fair coin. Now, we don't have time to toss it or flip it infinitely many times, but we may be able to flip it 100 times if we don't have much else to do. So this here represents the 100 trials, the 100 flips. It's kind of like a sample. We can think of it as a sample, in fact, a sampling of flips. So here, p hat, the sample proportion, if we're getting 51 heads out of 100 flips, and heads is success, well, the sample proportion would then be 51 over 100, or 0.51. That would be our p hat. And it would be our best point estimate for p. Maybe we don't know what p is yet. Maybe we don't know yet that it's a fair coin. But again, you can see how this is quite possible. How, if we had a perfectly fair coin, if anything, that's the hard part to conceive of. If we had a perfectly fair coin, then it's not so shocking that it would come up heads 51 times out of 100 in our 100 trials, where p hat is 0.51. So sampling error is something that comes naturally. Something like this should not be shocking. Our sample statistics the information from our sample may not be perfectly reflective of what's happening in the overall population, or what's actually happening with, in this case, the coin. Next, we're going to talk more about interval estimates. The idea that, well, let's see, if we have a sample proportion of 0.51, if we got 51% heads, well, 51% might be our best guess for what P is up here, 0.51. But if we were allowed a range of values, an interval of values, what would be reasonable? That's next time.